Tonight, step outside and look up. You see one moon, you have always seen one moon. But what if you hadn't? What if a second one hung right beside it, close enough to see craters with your bare eyes? It sounds like science fiction. It isn't as far-fetched as you think. Scientists have spent decades studying how our single moon actually formed, and the answer involves violence, chaos, and near misses. Somewhere in that story, a second moon almost happened. Here's what we know for certain. About 4.5 billion years ago, a Mars-sized object slammed into the young Earth. Researchers call it the giant impact hypothesis. Planetary scientists William Hartmann and Donald Davis first proposed it back in 1975, after wrestling with a question nobody could answer. Why does the moon have almost no iron core when Earth has a massive one? Their answer changed everything. A planet-sized body nicknamed Theia struck Earth at an angle. The collision vaporized rock, flung debris into orbit, and left behind a glowing ring of molten material. That ring eventually clumped together. It became the moon you know today. But here's the part most people never hear. That debris ring didn't have to form just one moon. Planetary scientist Robin Canup has spent years running supercomputer simulations of this impact, testing different angles, speeds, and masses. Her models show something strange. In many versions of the simulation, the debris briefly forms two bodies, not one, orbiting Earth side by side, two infant moons born from the same collision. So why do we only have one today? This is where it gets interesting. In 2011, researchers Eric Asfog and Martin Jutzi published a study in Nature proposing exactly this scenario actually happened. They suggested a second, smaller moon did form, roughly a third the width of our moon. For millions of years, it orbited quietly, then gravity pulled it back in. Instead of colliding at high speed and creating a crater, the smaller moon drifted into the larger one at a slow, gentle pace. Think of two pieces of wet clay pressed together rather than smashed. Asfog and Jutzi argued this collision could explain one of the moon's biggest mysteries. Why does the far side of the moon have thick, mountainous highlands, while the near side is thin and smooth? Their answer: the far side isn't scarred by an impact, it's built from one. Now imagine that second moon never merged. Imagine it kept orbiting, stable forever. What would that actually look like from Earth? For one thing, your sky would never be the same twice. Two moons pulling on each other and on you means constantly shifting phases, positions, and brightness. Some nights they'd sit close together, doubling your moonlight. Other nights they'd be worlds apart across the sky. Tides would change dramatically too. The moon's gravity already pulls our oceans into daily rhythms. Add a second moon and coastal cities would face far more complex and far more extreme tidal patterns. Some scientists who study lunar tidal forces estimate that a second moon of significant size could double or even triple tidal ranges, depending on its mass and distance. But could two moons even survive, long-term, in stable orbits around one planet? This is where physics gets unforgiving. Two moons orbiting the same planet constantly tug on each other. Small gravitational nudges build up over time. Add the sun's gravity into the mix, and orbits that look stable today can become chaotic within a few million years. Most orbital dynamics research points to one of three outcomes. The moons collide, one gets flung into deep space, or one spirals inward until it crosses something called the Roche limit, the point where a planet's gravity literally tears a moon apart into rings. So maybe two moons could exist, but could they last? Probably not forever, and that's the quiet twist hiding inside this whole idea. A two-moon Earth isn't just a fantasy about better night skies. It's a snapshot of instability, a system caught in the act of settling down. Our actual moon, single, steady, tidally locked in near-perfect stillness, might not be the exception to the rule. It might be the rule playing out to its natural end. Every crater on the moon's far side may be a fossil of a world that almost had a sibling. Every high tide on Earth tonight is a quiet reminder of a collision that happened billions of years ago, and maybe even a second collision after that. So the next time you step outside and look up at one moon, remember this. You're not looking at simplicity, you're looking at survival.